Welcome back to another video with the Math Doc. We're still talking about functions, and in this video we will introduce the idea of a linear function. Linear functions are the name linear comes from the word line here, line. But in particular, when we say a linear function, we're looking at functions that when we graph them are shown as straight lines. So it's not just a line, it's a straight line. And you can see here a few examples in the different colors of straight lines. These are linear functions. What does that mean that we have a straight line? Well, you might have heard already the term rate of change. And in this case, when we're looking at a linear function that will show up on a graph as a straight line, we're looking for a function that has something called a constant rate of change. And we will show what that means exactly for all four of these examples here. So when you leave this video, you'll know what rate of change means and also what it means for a linear function to have a constant rate of change. Now, the rate of change is basically the amount that y changes when we change x. What does that mean? Well, we can move with x. This is our x-axis here. It's a little bit small, and that's the y-axis. And if we move in x, say in this direction, by say 1 unit, from like 0 to 1 or from 1 to 2, by how much does y of the function change? So let's look at these examples, and as we work them out, I think you'll understand the term. So let's start with the blue example here. So let's change x by 1. Let's go, say, from 0 to 1. Okay, x goes from 0 to 1. So we change by 1. And y on this line also went from 0 to 1 here, right? If we mark the y on the y-axis, we also went from 0 to 1. So when we changed x by 1 unit, y changed by 1 unit as well. Let's now look at 1 to 2. What happens here when x goes from 1 to 2? That's all right. Let's keep this neat. From 1 to 2. So we've changed again by 1. Y will go from 1 here to 2, right? So again, our y went from 1 to 2, so it also changed by 1. So what is our rate of change? It's the change in y divided by the change in x. In this case, when we change x by 1, we also change y by 1. So our rate of change is equal to 1. That is the case for our blue line here. The idea, though, is that it's a constant rate of change. So if we look also at, say, x goes from, say, 6 to 7, okay, out here, 6 to 7. So we've changed x by 1. Y, let's see what y does. Well, we're here, right? Y goes from 6, and here's 7, also to 7. So again, the change is 1. So our rate of change is just 1 divided by 1, which equals 1. So no matter where we go on this curve, on this line, the rate of change is exactly the same. It'll be constant. Let's look at another example. Let's erase our markings here so that it's all clear. Okay. So let's now look at our red line here. So when we look at the red line, let's take x go from 0 to 1. In that case, our y went from 0 here, right? This is 1 here, to 2. It went all the way to 2. So y went from 0 to 2. So what is our rate of change here? It's y, the change in y, which is 2, divided by the change in x, which is 1, so that equals 2. Let's go do, say, x equals 2 here. X equals 2. We're at this point. Let's go from x equals 2 to x equals 3. So we go from 4 here in y to 6, right? You see how in this line, when x goes from, from 2 to 3, our y goes from 4 to 6. So again, our rate of change is just 4 to 6 is 2 units. Divide by our change in x, which is 1 unit, so it equals 2. So no matter where we go on this line, the rate of change will stay constant. So let's look at the other examples here. And in this time, when we look at the examples, we can also look at a change in x that is not just 1. We can look at faster changes. So let's look at our green line here. So let's take x goes from, say, 1 to 3. 1 to 3. Okay, so here x at y, when x is 1, is equal to a half. And when x equals 3, our y is actually 1.5. So half goes to 1.5. So what is our rate of change? Well, the change in y is 1.5 minus 1, right? That's how much we've changed. And the change in x is 3 minus 1, right? We went from 1 to 3, and we went from 1 to 1.5. So what is our rate of change? Well, sorry, here that was supposed to be a half. The change from 1.5 from a half to 1.5 is exactly 1. But our change from 3 to 1, or from 1 to 3, is just 2. So the rate of change here is a half, okay? It's a smaller rate of change than we had for the other two lines. Let's look at another 2 points. Let's look at 2 to 6, okay? So x goes from 2 to 6. Okay, so at 2, our y is equal to 1, right? And at 6, our y is equal to 3. So what is our rate of change? Well, we have 3 minus 1 in the denominator, and we have 6 minus 2 in our denominator, which means that we have 3 minus 1 is 2, 6 minus 2 is 4. We have 2 quarters, which is exactly equal to a half. So again, the rate of change has stayed constant. We still have rate of change equal to half, both in this jump here and this larger jump here. Finally, let's look at our final line here. Let's erase our markings so that we can look at it carefully. Now our final line here, the one in purple, is different because it kind of is shifted up here. It's not starting from what we call the origin, where x and y axes meet. But we still do the same thing. We can look at the rate of change. So let's look at the rate of change when x goes from, say, minus 2, negative 2 to 0. Okay, x goes from negative 2 to 0. In this case, y will go, so when x equals minus 2, we're up here, so y equals 1. And when x equals 0, y equals 2. So we go to 2. So what is our rate of change? Looking at the change in y, right, is 2 minus 1, while the change in x is 0 minus negative 2. As a reminder, when we're looking at a subtraction of a negative number from another number, we do minus minus, which ends up being plus. So we have here 2 minus 1 is 1, and 0 minus negative 2 is just 2. So the rate of change for our purple line is also a half. And it's interesting to compare the green line and the purple line here, these two lines. As you can see, they actually are parallel, and they look like they have the same slope. And that is very true. And what we learned from this is that the rate of change is the same as the slope. And I think the slope is a word that we're more familiar with from real life. We understand what the slope is. So the slope is the rate of change, how much we move up as we change x. We can also look at the other direction, but we won't complicate things at this point. So again, we just started with linear functions, just learned what a linear function is and how it's defined by a constant rate of change. If this video was helpful, please like. If you have comments, please include those below, and I will see you next time.